Let's take a look at differentiating a whole bunch of different types of function. Okay, in each case what we're going to do is we're going to make these equal to y. So I'll just write some of these out and we'll just work our way through them. So here we go. And by the way, we could express them either way, either as a f of x, or we could say y. So I'm going to start off, I'll just choose a few of these. So let's choose some interesting ones here. So number 3, we've got y. So I'll put 3 here, 3. By the way, this is exercise 2.02. This is in theta. This is theta mathematics. And I'll put exercise here, 20.02. Remember, you have this in the classwork stream on Google Classroom. So the first one, I'm going to make x equals 3x squared. So let's have a look. So I'm going to go dy dx is equal to, well, multiplying the coefficient by the power, 3 2s are 6. This is an x. Power is reduced by 1, becomes a 1. I'll write it in on this occasion, which is, of course, equal just to 6x. And there is my solution. Notice we write out the question, we state the function, then we apply the differential to that, and we write our answer, keeping equals as much as we can under each other. Very important to set it out this way because, of course, in an examination, in any type of assessment, you'll be expected to do precisely this. All right, some interesting ones. We'll look at number 14, line number 14. Look at that. It's very cool. So number 14, I'll write up here 14. So I've got x squared on 3 plus 6x. So I'm going to make that y is equal to x squared on 3 plus 6x. There it is. Okay, what's the coefficient here? Well, this is going to be a third. In fact, I could actually just rewrite that as y is equal to 1/3 x squared plus 6x. Nice and simple, really. Now, let's multiply the power by the coefficient because we're going to find the differential of y. Differentiating y with respect to x. Well, 2 times 1/3, well, is 2/3. And we're going to reduce the power by 1, which makes that an x to the power of 1, so I'm just going to leave it as x. Plus, I've got 6 times, well, the power in this case must be a 1. It's not, can't see it there, but it would be a 1. 6 times 1 is 6. Reduce the power of x by 1, well, x to the 1 becomes x to the 0. Anything to the power of 0 is 1. So it's really 6 times 1, which of course is just 6. And there is our solution. Okay, let's look at some other ones. There must be some other very cool ones here. Ooh, I really like number 4. Look at that one there. Here we go. I'm going to write it, show here. So we've got this one over here. Look at this one. Love this one. Here we go. So I'm going to write that out. So here we go. So what we're looking at here, and I'll just make a bit of a sidebar down here. In fact, I need a bit more room, really, but I'll write. In fact, this time I'm going to make it as a function. I'm going to call it f of x is equal to x to the 6 plus x to the 5 minus x to the 4 plus x to the, whoops, that should be an x to the 3, I'm just not doing very well here, an x to the 3 plus x squared. Just squeezed it in. All right, so now we want to find f of x, or f prime x is what we call that. So I'm going to go 6 times the coefficient, well the coefficient is 1, 6 times 1 is 6x, oops, must have an equals in there, sorry. Okay, 6x to the, and I'm going to reduce the power by 1, the 6 becomes a 5, plus, well, 5 times, must be a 1 there, 5 times 5 is, 5 times 1 is 5, x to the, in this case it's a 4, minus, so it's going to be 4 times negative 1, well 4 times negative is negative 4x to the, reduce the power by 1 becomes a 3, plus 3 times a positive 1 is 3, with an x, reduce the power by 1 is a 2, and I've got 2 times x is 2, x, reduce the power by 1 squared becomes a power of the 1, and there is our differential. Like that one, that's very cool. All right, let's see what else we got here. Oh, I like number 25. Look at 25. 25 is kind of looking a weird looking one, yeah? Oh, I'll do number 11 as well. X minus 1. Let's do x minus 1 first. So I've got of course, y is equal to x minus 1. So I'm going to find the differential of y with respect to x. So let's take all the x values. Remember, we're differentiating y, which is the whole thing, with respect to x, not with respect to 1. So this is going to be the x, it's a power of 1, 1 times the coefficient, which is 1. 1 times 1 is 1. This becomes now a 0, and 0 times anything to the power of 0 is 1, and 1 times 1 is 1. So, and of course this just falls away, so the answer is just 1. Okay, very nice. What else have we got here? I like that one down the bottom there we had. What was it? Px plus Qx. I love that one. And on this time I'll make it a function. Yeah, I've got a function of x, here we are, is equal to p x plus qx. Okay, so what do we got here? We've got, well, the power here is going to be 1. 1 times p is p. So f prime x is going to be p. And this becomes now a 0. X to the 0 is 1, so it's p times 1 is p, plus, and this is going to be the same. It's going to be a q, because q times the power here is going to be 1. 1 times q is q. This becomes a 0, which makes x to the power of 0, 1, and q times 1 is q. And there is our solution.